Today we will use the perpendicular bisector theorem and the angle bisector theorem to solve some problems. So if you look at your worksheet, the first theorem we'll look at is on perpendicular bisectors. The theorem states that if a point lies on the perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. So in this diagram, we see that line CD is the perpendicular bisector of AB. As you can see, CD is perpendicular to AB, and it also bisects AB, meaning it splits it in half, and we can see that with these marks. So if line CD is perpendicular to segment AB, and segment AD is congruent to segment DB, then C is equidistant to A and B. AC is congruent to BC. Those are the conclusions we can make. The converse of the perpendicular bisector theorem also applies if a point C is equidistant from the endpoints of a segment, in this case A and B. In this case CA is congruent to CB. Then it's on the perpendicular bisector of the segment. So once again, if AC is congruent to CB, if there's a point that's equidistant to the endpoints of a segment, then that means it lies on the perpendicular bisector of that segment. So what we can conclude with the converse is that CD is the perpendicular bisector of AB. CD is perpendicular to segment AB, and AD is congruent to DB. So let's work on some examples. In number 1, we have to find the value of x. We see that we have a perpendicular bisector here. So this point on the perpendicular bisector is equidistant to the endpoints of the segment that it bisects. So 7x plus 24 and the side marked 13x minus 48 are congruent. So let's just do the algebra to solve for x. So here's the perpendicular bisector theorem. Allows us to make this equation. And so subtract 7x from both sides. Add 48 to both sides. Divide both sides by 6. Number 2, we have this point that's equidistant to the endpoints of a segment. That means that it lies on the perpendicular bisector. So this line that I have outlined in blue is perpendicular and it bisects the segment. So with the converse theorem, we get 17x minus 3 equals 9x plus 13. Subtract both sides. Subtract 9x on both sides, you get 8x minus 3 equals 13. Add 3 to both sides. 8x equals 16, and x equals 2. Next, we have to find RS. So first, we have to find x in order to find RS. So since RT is the perpendicular bisector of QS, then R is equidistant to Q and S. This is what we know. 7x minus 22 equals 4x plus 5. Subtract 4x on both sides. 3x equals, add 22 to both sides, 27. X equals 9. So x equals 9. Therefore, RS equals, plug it in, substitute. Instead of x, we write 9 plus 5, and that equals 41. Number 4, find EG. This one here. So first we need to find the value of x. D lies on the perpendicular bisector of EF. So we know EG is congruent to GF. 14x minus 37 equals 2x plus 11. Subtract 2x from both sides. Add 37 to both sides. Divide both sides by 12. And x equals 4. EG is 2 times x, which is 4, plus 11. EG equals 19. Number 5. Find segment AB. So let's circle what we're trying to find here. Point C is equidistant to A and B, so point C lies on the perpendicular bisector of AB. So find x, 5x minus 11 equals 3x plus 17. Subtract 3x on both sides. 2x equals, add 11 to both sides, 28. X equals 14. Oh, that's not the final answer. We get, let's find AD. 5 times 14 minus 11 equals 59. We know that DB should also be 59. Let's check our work. AB equals 3 times 14 plus 17 equals 59. Oops, that was DB. Sorry. I apologize. DB. So that's 59. And so AB will be 2 times 59, which is 118. That's the final answer. Then we have JK. We need to find segment JK. So we see that KM is the perpendicular bisector of JL. K is equidistant to J and L. So 6x minus 26 equals 3x plus 34. Subtract 3x on both sides of the equation. 3x minus 26 equals 34. Add 26 to both sides of the equation. 3x equals 60. Divide by 3 on both sides. X equals 20. That's x. We need to find JK. JK is 6 times 20 minus 26, which equals 94. And that was using the perpendicular bisector theorem and its converse.